your data handbook with you. Are you there? Is the screen visible for you people?
Yes, sir, it's visible.
Yeah. Take out your data handbook and go to table 6.1, page number 93. Go to table 6.1, page number 93. Are you there?
Yes, sir.
Yeah. So there are many figures. Along with that, you have got equations for finding out normal stresses, shear stress, and so on, right? Something like this, you will have equations along with the sketches. Is it okay? Fine. So when the problems based on such loading conditions are given, we need to refer to the appropriate figure from table 6.1 in page number 93 and then choose that equation to calculate the required parameter. This is what we need to do. Okay, fine. So now take down this problem. This was asked for 8 marks. So I invite you, just note down this problem. Determine the allowable stress in the joint as shown in figure if the weld size is 10 mm. Please note down this problem. Please note down the problem. Note down the problem and sketch. See, along with the sketch, that equation will not be given. Okay. So just for taking the sketch as a reference, I have taken this. So this will not be there with you. You have to identify the similar or the same sketch from data handbook from table 6.1. Okay. And then get the appropriate equation to solve the problem. Okay. Determine the allowable stress in the joint as shown in figure if the weld size is 10 mm. So in the problem he has given you, it is subjected to M. He has given there M is equal to 1 kilonewton meter, and also he has given the diameter of the shaft as 25 mm. Okay. Okay. Shall we go ahead with the solution discussion? Did you finish? Finish noting down?
So 1 minute.
Just note down the problem and this sketch along with the data. Data is given in the sketch. Okay, finished with the sketch? Yeah, someone should answer back.
Yes, sir.
Yeah, so from the given problem, we have got diameter D is equal to 25 mm, and the shaft is subjected to a moment of 1 kilonewton meter given in the problem, and value of weld size is 10 mm. He has given you in the problem. Okay, go to table 6.1 and look for this sketch where a circular shaft is subjected to a bending moment. Okay, and fillet weld is H over here, right? So look at the problem and let me know the problem number. Figure number there. Is figure number given in the data handbook? Just check.
No, sir, figure number is not given.
Figure number is not given. So could you identify this sketch in the table 6.1
is the seventh one.
seventh one. The circular shaft subjected to bending moment. Okay, could you get this? All of you, could you get this?
Yes, sir.
Yes, sir.
Yes, sir.
Fine. So there you are given with normal stress to be equal to 5.66 times moment divided by pi h into d square, where d is the diameter of the shaft, h is the weld size, m is the moment that it is subjected to. Okay, so substitute the equation. So I write down that equation, substitute the values, get the value of sigma. That's it. That's all you need to do for 8 marks. The only challenge is, out of so many sketches over there, you need to identify the correct sketch. Then things are all quite simple. Just get me this value. If you have got this value, let me know. We'll go to the next problem.
So this one step is for 8 marks.
Huh?
This one step is for 8 marks, sir.
Yeah. Shall we go to the next problem if you are finished?
Yes, sir, finished.
Yeah, take down this problem. I think this is, again, this was asked in another, determine the allowable stress in the joint as shown in figure, taking allowable stress in weld as 70 megapascal. Please note down this problem. And this is the sketch that you need to note down. Sketch is given along with the question. Okay, what is it is subjected to? What it is subjected to now?
Torsional.
Yeah, it is subjected to torsion. So the stress value that he has given you here, 70 megapascal, is the shear stress. Okay, so you should not get confused, because moment and torsion, if they look both similar, so you should be in a position to identify whether it's torsion or moment. Please note down and get me the value of weld size, because you are asked to find out allowable stress in the joint. I think you have to find out weld size. Okay, not allowable stress. Just change the problem over there. Determine the weld size. Okay. Determine the weld size for the joint as shown in figure, taking allowable stress in the weld as 70 megapascal. It is given that T is equal to 300 Newton meter and diameter is equal to 60 mm, given in the problem. Okay, and this is a circular shaft subjected to torsion, and this circular shaft is welded to another metal piece. So we have to find out the weld size H. Okay, solve the problem and check whether you are getting the same value as what I have got. This T is 300 Newton meter. That is the torsional moment, 300 Newton meter. So that I converted it to Newton millimeter. So that this is 70 is in Newton per mm square, diameter in millimeter. So therefore, convert the torsional moment from Newton meter to Newton millimeter by multiplying it by 10 power 3. Once you have finished, let me know.
Done, sir.
Done. Others, anybody needing time? Srivatsan,
No, sir. I wrote.
finished, huh?
Sir, shear stress is 70 and you've taken as 60 in the thing.
No. Oh, okay. Here, no. Then will the value change over there?
No, sir, the answer is correct.
Yeah. While typing, maybe. Okay. Now it's okay. It's okay now? No.
Yes, sir. Yes, sir.
Yeah. Next we'll go to. So this is the type of one type of problems that we can get. So far what we have done is, so the welded joint subjected to axial loading. Okay, this is what we did over here. Welded joint subjected to axial loading. Then we went to welded joint subjected to transverse loading, and then we solved some standard problems. Okay, where with the joints, welded joints subjected to bending and torsion. And now we'll go to the final type of design of welded joints. Okay, so that's called eccentric loading of welded joints. So how to solve or how to design when we are given with eccentric loading of welded joint type 2. Okay, it's a second type of problem. So for that, if you look at the design procedure, again, we need to find out total length of the weld, LT I call it as, direct load per unit length, PD. So just like what we did previously for type 1 type of eccentric loading, that is load divided by total length of the weld, and the unit is going to be Newton per millimeter. Okay, so that is the direct load per unit length. Now, only difference is we need to find out ZW for top and bottom both. Okay, and then we need to choose smaller value. Go to table 6.7. Please go to table 6.7. Are you there in table 6.7?
Yes, sir.
Yeah, I'll just open that. Table 6.7. Yeah. So now, if you look at section modulus in bending, is that visible for you people? Is the data handbook visible on the screen?
Yes, sir.
Yeah.
With
So here, if you look at the various joints out there, right? If you look at the first one over here, section modulus in bending, okay, is one here. One equation is for top, another is for bottom. Okay. So like that. So top and bottom we are given. So for a given welded joint, we need to find out section modulus both for top layer and bottom layer. Okay, and choose the smaller of these two values for further calculations. Are you all there? Are you all there? We need to find out both Z for top layer, Z for bottom layer as well, and choose the smaller of the two values for further calculations. Are you clear now? Yeah?
Yes, sir.
Okay. So this is the another table 6.1. This is what I was talking about in the previous example, where when the circular shaft subjected to torsion, circular shaft subjected to bending moment over here. So similarly, you will have rectangular square joints, okay, subjected to transverse load here. So you'll have shear, normal stress. So on, depending upon the given sketch, we need to choose these figures and the equations appropriately and then solve the problem. Right? So now come back to the problem now. Yeah, right? So for the procedure number 1 is to find out total length of the weld. Okay, so that will give you LT, then direct load per unit length, then find out ZW for top layer and bottom layer. Note is choose smaller value of these two. That's the highlight. Next, find out normal load Pn, that is given by P into E by Z. So the Z is nothing but ZW. Okay, they are not the same. So whichever is smaller value, that you substitute over here. E stands for eccentricity. And then resultant load PR is equal to PD square plus P square N, that is normal load. And as usual, for using the shear stress equation, we can find out the weld size. Is that okay? Is that okay? Please note down the procedure. Type 2 eccentric loading of welded joints, type 2. Okay, note down the design procedure. Okay, and this is very, very important. Choosing smaller value of ZW.
So why are we choosing the smaller value?
But for safer design, that's all. We assume, say for example, what is sigma normally which is subjected to bending? It is given by M by Z, correct? So if I assume smaller value of Z, my stress will be larger. So I tend to choose a safer section modulus. That's it. Okay?
So it becomes larger stress now, sir.
No. See here, what will happen is I have to, where you mean to say here, section modulus and stress you are talking about?
Yes, sir.
Yeah, that is what. See, when I choose smaller value, then I'll get bigger stress. Okay, then what I do is, I try to curtail this by increasing the section modulus.
Is it like you can like accommodate bigger stress, or bigger stress is not?
Yeah, if material is fixed, then we cannot change the stress value. Then we have to increase for section modulus. Go for section modulus. Change. Because if you choose C40 steel and factor of safety of two. Sorry. Okay, are you there?
Yes, sir.
Yeah. Please note down the design procedure. As I said in the very beginning, I think it is Allowable, no?
Yes, sir.
Yeah. I said in the very beginning, no problem will be structured. Okay. So any design problem is unstructured only. So we need to start somewhere and then arrive at, do iterations and then arrive at a final solution or a product. Like that it is. So there will always be changes in material, changes in section moduli, changes in load taking capacity, and so on. So it's always a permutation combination like thing, where from unstructured we tend to move towards structured, but never it is going to be structured. And I'll tell you one more thing. Okay, I think you can understand. What we do normally in assumptions for any law, we assume material to be what? What is that we assume? Material to be
For what, sir?
homogeneous, correct?
Okay. Yeah.
But as we go higher in your subject, the Norton is the number one in the world for design, right? So he says no metal on earth is homogeneous. Okay, so that is one thing. Another thing is what is that? Yeah, in the stresses we assume the stresses to be linear. Okay, but when you go advanced to theory of elasticity and stress in three directions, there it can be easily proved that stress will never be linear. Okay, so these are the things that are there at micro level. Okay, so
So
there,
won't there be like an error generated if you consider it as linear and do it?
that is what that error should be sustainable. That is, that error should not exceed, or we always reach closer to realistic value. That's all. All these assumptions are made just to know we will not get exact solution, but we will be close to exact solution only all the time.
Okay, sir.
Okay, so
Sir, how was this kind of weld different from what we were doing till now?
yeah, we'll go to the next problem, then you'll understand it now.
Okay.
Finish with this?
Yes, sir.
Yeah. Yeah. Okay. Can you see the difference between what that welding and this welding was? So this is attached with multiple welding zones, right? So where is the here is the problem? Yeah. Note down this problem. Determine the size of the weld for a bracket loaded as in figure. The allowable shear stress for the weld is 75 megapascal. So there it was only parallel and transverse fillet welds. So here it's going to be totally different type of welded joint that we are handling now. Okay. So please note down the problem. Determine and figure also. Okay. This is 125. This is 200 here. 960. That is the value of eccentricity. And load is 30 kilonewton. Note down the sketch. Determine the size of the weld for a bracket loaded as in figure. The allowable shear stress for the weld is 75 megapascal. And these are all the water blue shade that I have shown here. They are the welds.
So what is the meaning of eccentric weld?
Eccentricity. Eccentricity is the distance between center of gravity to the point of application of load, where the joint is expected to undergo rotation. Okay, about which the joint is expected to undergo rotation because of the applied load or torsional moment. Is it okay? It's like center of a circle. That's it.
But eccentric loading, what does that mean, sir? In this case?
Eccentrically, can you see the figure that I'm drawing on the screen?
Yes, sir.
Okay, I take a column, something like this. Okay, and this is the axis, geometrical center of this shaft. Now, if I apply load along the axis, then we call the load to be acting along the axis, or it is called axial loading, or okay, axial loading is what we call. Now, for the same column, I apply load here. Okay, I apply load here. Load P I am going to apply here. That is at a distance, I call it as E. Okay, from the geometric center of the column. Then this type of loading is called eccentric loading. That is loading which is acting away from the geometric center or center of gravity. Then we call it as eccentric loading. Okay?
Okay, sir, got it.
Yeah. And here this 200 is not up to this, it is only up to this. I think it's a small change. Okay. This is 200. Please change, please correct in your sketches. This is 200, this is 125. Did you finish with the problem? Problem and sketch?
1 minute, sir.
Yeah. Okay. Hope you are finished with the sketch and the problem. Just follow the procedure. Find out total length of the weld, which is nothing but 200 plus 200 plus 125 plus 125. Okay. Put together is 650 mm. Just check the calculations. Then find out direct load per unit length, PD, which is given by P by total length of the weld, LT. So P is 30 kilonewton given in the problem. Okay. The welded joint is subjected to 30 kilonewton load. So 30,000 divided by 650 will give you 46.15 Newton per mm as direct load per unit length. Eccentricity given in the problem to be equal to 960. Then find out ZW and you'll get this value over there. Substitute for N and M. N is 125, M is 200. Okay. So this is N and this is M. This distance, we take it as M. Okay. Then find out normal load, resultant, and size of the weld. Calculate and let me know the value of size of weld. Just follow the steps of the design procedure and get the final value of size of the weld. Are you getting 15 mm? So what you need in the table 6.1, what you need to do is see is one weld here, one line over here, one line vertical and another line horizontal. You should look at the joint, okay, which is shown like this. It is not double line, it's a single line, okay? Don't get confused. Are you getting this figure and this equation? Are they matching?
Yes, sir.
Section, yeah, they are matching, no? Section modulus. Finished with this problem?
Yes, sir.
Yeah.
So 1 minute. One
Yeah,
minute.
yeah. Take your time.
So can you scroll down a little?
Yeah.
Yes, sir.
Done? Shall we go to the next problem?
1 1 minute, sir.
Yeah.
Done, sir.
Done, na? Okay. We'll take the next problem. Yeah, please note down this problem. Determine the size of the weld for a bracket loaded as shown in figure. The allowable shear stress for the weld is 72 megapascal. Note down the sketch. And solve the problem. Yeah, please solve the problem and let me know the answer of size of weld. Meantime, Sai Sumant,
Present, sir.
you are 1, no? 001.
Yes, sir.
Okay. Abhishek Narayan. Akram Anwar. Akram Anwar. Akshat BS. Ala Pundyur.
Present, sir.
Pundyur, what is your number?
8.
008. Okay. Ankit Gangadhar.
Present, sir.
9, no?
Yes, sir.
Okay. Ashtesh Nadella.
10 present, sir.
10. Okay. Biban.
Present, sir. 11.
11. Okay. Chinmayi 12, no?
Present. Yes, sir. Present.
Okay. Chaitanya Patel. Chaitanya.
Yes, sir. Yes, sir. Yes, sir.
400, no?
No, yes, sir. 400.
Okay. Darshan.
Yes, sir. 15.
Number.
15. 15.
Jain Bansali.
Present, sir. 22.
22. Jitin.
Yes, sir. 23.
Okay. Vamshi.
Sir, excuse me, sir.
Yeah. Chaitanya Vamshi. Are you there, Chaitanya?
Present, sir. 24.
Chaitanya Vamshi 24.
24, sir. Present.
Okay. Anwar I have taken. Anwar I have taken. Yeah. Kartikeya Avasti.
26, sir. Present.
Mahima Raj. 26, no? Again.
Yes, sir. 26.
26 Mahima. Okay.
So can you scroll down?
Scroll down. What is the value you got, W? I'll scroll down. Tell me the value of W.
Doing so, 1 second.
Yeah, do it. Follow the same procedure and solve and let me know the answer. Next, Narendra Sadanand.
Present, sir. 33.
What is the number? 20?
33, sir. 33.
33. Okay. Nihal Shetty.
Yes, sir.
Number?
34.
And Nimala Vagmesh, Prajwal, Mulepati.
Yes, sir. Prajwal, sir.
Prajwal, what sleeping?
No, sir. This
Tell me number.
39, sir.
39. Mulepati.
Present, sir. 66.
66. Okay. Prayag, what Devan?
Yes, sir. 40.
Prayag, did you get your marks? Again?
Yes, sir. I got it. Yes, sir.
Okay. Don't do that mistake again next test. Okay, if you are taking.
Yes, sir. Yes, sir. Yes. Okay. Thanks.
Pinto, Pinto,
Yes, sir.
number.
42, sir.
Rakir,
Yes, sir. Sir, roll number 43.
43. Ramesh, yes.
You guys are not going to leave me.
Ramesh, yes.
Present, sir.
Number.
Present, sir.
Huh?
403.
Prajwal, switch off your mic.
403.
What, Ramesh? Now, what's your number? Ramesh.
403, sir. 403.
ಅದೇನ್ರಿ ಸರಿಯಾಗಿ ಹೇಳ್ರಿ ಅದೇನ್ರಿ ಹಂಗ್ ಮಾತಾಡ್ತೀರಾ ರಿಷಿ ದಿನೇಶ್ವರ್
403 he's saying, sir.
Okay. Rishi Dineshwar?
Present, sir. 44.
44. Then Sanjay Gowda?
Present, sir. 47.
Okay. Sanjay?
Yes, sir. Present. 48, sir.
Okay. Satish Shankar?
Yes, sir. 49.
49. Okay. Saurabh Praveen?
Yes, sir. 50.
50. Next, Shivam Kumar?
Yes, sir. 52.
Okay. Shivam Sundriyal?
Yes, sir. 53.
Okay. Saluja?
Yes, sir. 54.
What, Saluja? Where were you for a long time? Huh? Happily bunking. No point.
sir. I attended all the classes, sir.
Oh, is it? I think it's different, I think then. Siddharth Sanu. Oh, that is Siddharth Sanu, not Shravan Saluja. Okay. So, Sautri Kroy?
Present,
Yeah.
sir. 1755.
Sautri Kroy, 17?
1755, sir.
55, no? Okay.
Yes, yes.
Srivatsan?
Present, sir. 1756.
Yeah, got it. Tarun Pachori, 60, correct? Huh?
Yes, sir.
Vinay J?
Present, sir. 61.
61, okay. I think that's it. Finish the problem? Yeah, what is the value of W? Yeah? What is the value of W? Can you hear me? Yeah? Can you hear?
W is 20, sir.
W is 20, correct. Yeah. Others, please check your answer. Total length of the weld is 500 mm. Okay. 200 plus 100 plus 200. Okay. 500 mm is the total length. Direct load per unit length, you will get 40 Newton per mm. Eccentricity given in the problem is 900. Okay. Anybody, any doubt here? Any doubt?
So what is PE? What
is? P
PE?
into E. P is 20 kilonewton. Okay. So 20 into 1000 Newton. The eccentricity is 900 mm given in the problem. And Z value for top, it is 26.67 into 10 power 3. And for bottom, section modulus is 17.7 into 10 power 3. So we know that we need to choose smaller value of section modulus. Okay. So therefore, choose 17.77 into 10 power 3. And you are going to get normal load to be equal to 1012.94. Okay. And finally, the weld size that we are going to get is 20 mm. Anybody? Any other doubt? Any doubt in this? Okay, shall we go to the next problem?
Yes, sir.
Anybody needing time to note down? Srivatsan, Sautrik Roy, noting down?
So 1 minute. 1 minute. Sir.
Yeah.
Yes, sir. Just a minute, please.
Yeah. Yeah, then you should tell me no. You cannot keep quiet. We'll take up the final problem of the welded joints. Okay. Shall we take the next problem?
Yes, sir.
Yeah. Note down this problem. Determine the load carrying capacity. So we need to find out the value of P, okay, of a welded joint loaded as shown in figure. The allowable shear stress for 10 mm weld size. So W is given over there, okay. W is given. 10 mm weld size is 50 megapascal, okay. So it's a circular weld, right? So what you need to do to find out total length of the weld. Please note down this problem and solve this problem and let me know the answer. Diameter is 50. So the welding will be around that 50 mm diameter. So length of the weld is going to be how much? How to calculate length of the weld?
Circumference pi into d.
That's all. That's it. That's it. I hope others also got that. Pi into d will give you the circumference of circle, that will give you the length of the weld, right? So use that total length of the weld, calculate the value of P and let me know the answer. Yeah, what is the load carrying capacity of the weld?
So is it 771.8 newtons?
771.8, yeah. 771.16 is what I got. So 771.8 is also fine. Yeah, others, please check your values. Total length of the weld is given by circumference of a circle, that is pi into d, that is pi into 50, will give you 157 mm as the total length of the weld. Then direct load per unit length, eccentricity, ZW, okay, is given by pi into m square by 4. So in this case, that m is nothing but d. Okay, then find out normal load, resultant load, all in terms of p. Okay, normal load in terms of p, resultant load in terms of p. Okay, direct load in terms of p. And then finally substitute in tau is equal to PR by 0.707 W. So W is known 10 mm, PR is in terms of P, tau is given as 50 mm given in the problem, right? So solving that, you will get 771.8, Tarun? 8 is what you got?
Yes, sir.
Yeah, that's fine. So somewhere around that. Others, please note down this solution.
I took only 0.458 p. That is why I got that answer.
Which
You
one?
took 4 decimals.
Oh, you have taken 3 decimals, huh?
Yeah. Yes, sir.
Okay. Suddenly I've taken 4 decimals this time. Normally I don't take so many. I don't write so many decimals. So I don't know how I have gone up to 4 decimals. Normally I stop at 46.46. So anyway, it doesn't matter. That much variation is allowed. Others getting the value? Jayant?
Yes, I'm doing.
Yeah, please do. Jitin Kumar?
Yes, sir.
Please get the value and tell me after you get the solution. Sanjay Gowda? Working? Sanjay?
Yes, sir.
Okay.
Sir, isn't it supposed to be square?
Pardon me?
For PR, 0.4.
Underwood? Yeah, either way you can do, not an issue. Add these two, okay, and then take a square root of it and then square it. You will get that. That's it. Since this value is very, very small, you get same value out there. This is 0.00006.636. So therefore, it is negligible because already we are crossing. If you take 4 decimals only, so it will be 0.000, then 6. So automatically there is no much change here. It's a very small value. And over and above. Finished? Finished with this?
Yes, sir.
Finished, Jayant?
Yes, sir. Done.
And Sanjay Gowda?
Yes, sir.
Finished,
Yes, sir. Yes.
Okay. Right, so this is the total welded joint. Okay. Welded joint is, so far what we learned in welded joints is I'll just take you through what all that we did in welded joints right from the beginning. So where we started is the definition of welding, correct? We started off with definition of welding. So it's a process of joining two similar or dissimilar metals by heating to a suitable temperature, that is melting temperature, with or without the application of pressure. And we have two basic types of joints, lap joint and butt joint. So lap butt joint will have one metal piece butting against the other. In lap joint, one metal piece above the other. So welding is done. So these are various types of joints. This is parallel fillet weld. We fillet as parallel fillet weld. This is the weld is parallel to the axis of loading. Okay. Then we call it as a parallel fillet weld. When the welding is perpendicular to the axis of loading, then we call it as transverse fillet weld, right? So we have single transverse and double transverse fillet welds. All right. Then we learned about the cross section of the weld, and then we learned about the type of stresses that the parallel fillet and transverse fillet welds are subjected to, and total load is shared by load because of normal fillet weld and load because of parallel fillet weld, right? So that we took, and then we solved few problems based on that. And then we went to eccentrically loaded welded joints type 1, where the load is applied in transverse direction, and we learned about terms M, N, then radius, so location of center of gravity, eccentricity, and so on. Then we followed a design procedure to find out the weld size finally, and then we solved few problems based on that. Then we went to another type of problems where the welded joints are subjected to moments and torsional moments, bending moments and torsional moments appropriately from table 6.1. We choose appropriate sketches and equations and then solve the problems. Then we learned about eccentric loading of welded joints type 2, and then we solved few problems based on that. Okay, this is what we did in welded joints. Okay, and one more thing is I have posted assignment. Okay, I have posted assignment in Google Classroom. You all, I hope you all got the information. Okay, did you get that assignment in
Yes,
Google?
sir.
Please
Yes,
finish it. Please finish it before Sunday. Don't wait till Monday. Even the given time till Monday 7 p.m. Don't wait till Monday. And I'll tell you, I think first assignment only 27 hours only submitted before time. So remaining people will lose their 5 marks straight away. So therefore, assignment submission is compulsory before time. All right. So submit the assignment in time. Okay. Solve those 4 problems and submit in time. Okay. All right then. Okay. So from tomorrow I'll be starting with riveted joints. So don't miss class. First class especially don't miss. So we'll start with design for riveted joints. Is that okay?